One of the most interesting questions about our universe is how it was formed. God? Aliens? Well, the scientific answer to this question is the Big Bang Theory. According to the Big Bang Theory, everything in the universe, matter, energy, forces, space, time, was condensed in a small point, known as singularity. And then, 13,700 million years ago, the universe started to expand.
Wait, you've got to be kidding me, right? That seems impossible.
Yes, Flasky. It is true that some scientific hypotheses look too difficult to understand, but when thousands of observations and experiments support them, they end up being a strong theory difficult to refute, like this one.
Okay, so which are these observations and experiments you're talking about?
Well, we can look at the events of the past with really powerful telescopes and sensors, able to obtain images and signals so far away that show us a primitive universe, as they were produced thousands of millions of years ago. But these telescopes and sensors are not able to show us the first instance of the universe. For that, we need super advanced laboratories like the CERN in Switzerland, where small particles are collided at a really high speed to understand what matter is made of and to recreate the first moments of the universe. What we know already is that during the first second after the Big Bang, a lot of things happened. The first event was the separation of the four basic natural forces that exist in nature. The first one to separate was gravity, the force that attracts objects with mass, that keeps planets orbiting around stars, satellites around planets, and people attached to the ground. The second one to separate was a strong nuclear force. This force keeps the protons and neutrons together in the nucleus of the atom, and its name is not meaningless. We obtain nuclear energy when we break the nucleus of an atom, so you can guess how strong this force is. When the strong nuclear force separated from the rest, the energy released was so intense that the universe inflated like a balloon and matter distributed heterogeneously through space. And that's why some areas of the universe have more matter than others. Finally, the two remaining forces separated: electromagnetism, responsible for electricity and magnetism, and the weak nuclear force that helps with the stability of the nucleus. When we break the nucleus to obtain nuclear energy, the weak nuclear force is responsible for the radioactivity produced.
And have we proved that all these forces could be together?
We have been able to connect both nuclear forces with electromagnetism, but the connection between gravity with the rest of the forces remains a mystery. Some theories have tried to find the connection, at least theoretically, like the famous string theory, but right now it's the major goal of the best scientists in the world.
Why is it so important to find that connection?
Well, Flasky, if you like science fiction movies, understanding how they relate would allow us to control gravity with endless possibilities. Spaceships with its own gravity, curved cities. After the forces separated, the first elementary particles appeared.
You mean the particles that form matter, right?
Well, right now the universe is made of matter, but in the beginning two things existed: matter and antimatter, particles and antiparticles. The problem with matter and antimatter is that they come into contact, they mutually destroy and produce a lot of energy. Technically, all the matter and antimatter should have been destroyed, but there was more matter than antimatter, so that's why the universe and us are made of matter now and not antimatter.
Whoa, that antimatter thing looks dangerous.
Yes, Flasky, we have been able to produce and isolate antimatter. In the future, it could be an important source of energy, but also another way to make powerful bombs. Let's continue. The first particles to appear were the bosons, particles that carry out the function of the basic forces. The photon, the particle of light, for electromagnetism. the Z and W bosons for the weak nuclear force, and the gluon for the strong nuclear force.
And what about gravity?
As we saw before, gravity leads to many questions. How did it separate? Why is it such a weak force? What are the bosons related to it? One boson that seems connected to gravity is the Higgs boson, a particle that gives mass to other particles. But it's not enough to explain gravity's behavior, so scientists have proposed that there is another boson that hasn't been discovered yet, the main boson that controls gravity, the graviton. After the bosons, the next particles that appeared were quarks, the building blocks of protons and neutrons. Soon after the quarks were formed, the first protons and neutrons appeared. During the first minutes, the first leptons showed up. Leptons include particles like electrons present in atoms around the nucleus, other particles similar to electrons like muons or tau, and neutrinos, particles that don't interact with anything, also called the ghost particles. Once the universe contained protons, neutrons, and electrons, what do you think appeared?
Atoms?
Exactly. The first atoms of hydrogen and helium were formed, the most abundant elements in the universe. We use places like the CERN to understand the first steps of the universe because we can get pictures of this primitive universe. The oldest picture we can get from the past, obtained with microwaves, is 13,320 million years old.
But why can't we look into the first 380,000 years of the universe?
During these years, matter was so dense that photons of these microwaves were unable to escape and travel to us to give us pictures of the old universe. After this intense period, the universe started to cool down. Matter started to aggregate and bigger objects appeared. Stars, planets, galaxies, nebulas, until the universe ended up the way we see it nowadays.
Well, that was an interesting journey.
Wait, there's more. Until a few decades ago, we thought the universe was made only of matter and vacuum. Right now, we know that ordinary matter is a small portion, and that the universe is made of two other things. Another type of matter that we can identify as it produces gravity but that can't be seen, called dark matter, and a type of energy that accelerates the expansion of the universe, dark energy. There are still many questions about dark matter and dark energy, but as we can see, they are much more abundant than ordinary matter. Understanding the origin of the universe is really important, and not just to satisfy our curiosity. These findings could change science and technology forever, and what seems impossible right now could be a reality in the future.